Got a very special edition of the show today. I am your host, Ben Thomas. We're talking a little bit about the state of the industry, where we are from a residential power perspective, because when you look at power, historically, it's been this mystical hidden wire system that we don't really know how to track. We can't quantify. The end user doesn't really know how to install it. So the burden of our community, not only the technology, but the electricity and the electrician side, lives together when we start talking about some of these power systems. And you look at shows like CEDIA and all these different organizations, it's really the manifestation of these two industries coming together. And as we continue to integrate technology into our homes, and we look at things like EVs and chargers, which is a whole different conversation altogether we might get to a little bit today, but the role of the power supply and the power management systems in the home and residential spaces is incredibly important. So with that importance, I wanted to bring on somebody today, obviously, that is the king of really residential energy, I would say, as a whole, and that's Joe Piccirilli. Joe, obviously, that's a heck of an introduction, but we're very excited to have you on the show again today.
Well, it is my pleasure, Ben, and I'm going to try really hard to live up to that reputation, and I appreciate it, but I'm looking forward to our conversation because I think it will be wide-ranging and fun. So thank you so much for having me come on.
Of course. Well, it's your show. It's your show. I mean, I'm just in here enjoying this. This is great. I get to come in and fill the shoes of you for a day, and you get to be a guest on your own show. But I think it's really fun today for us because not only do we get to have some conversations about, okay, where's the industry going? What are we looking at 5-10 years? We also get to have a really meaningful and impactful conversation about where the industry is right now. And I think that, when you look at whether it's integration partners, hardware manufacturers, even end users in some cases, there's just so many questions about power, right? And what is the amperage? What is the wattage? Should I go renewable? What are my backup systems? What should that be? It's an enigma, right? And there are only a handful of folks really who are equipped to answer a lot of those questions. So we're going to try and set the table today a little bit with that. So the first place I want to start is definitely on the residential specific side, both on probably the single family home and the multifamily unit, right? Where are we in terms of adoption with power management? Not even reserves quite yet, but where are we in terms of automated power management in these spaces specifically?
Well, it is one of those fields that because there is fear and confusion, people are afraid of electricity. We are taught from the time we are very young children, stay away from your electrical outlets. And of course, some of us who are a bit more mischievous, of course, would plug bobby pins and stuff in the electrical outlets and figure out that wasn't a smart idea. And also, as we have progressed and created a tremendous number of microprocessors and mini computers in our homes, the effects of power quality have become much more obvious in today's world than they were just 10 or 15 years ago. When I was growing up and they first introduced VCRs into a home, the consequences of the utility, a micro outage or a power fluctuation, was your digital clock on your VCR would blink, and then you would have to reset it. And that was a major consequence because back then people hated resetting their digital clocks. But in today's world, all of a sudden, the consequences of power quality or poor power quality can be your lights don't work because a microprocessor that controls your lights is no longer functioning. You have plumbing that is controlled by microprocessors. Obviously your networks, any communication, all your AV equipment, all your security, all of those things are now microprocessor intensive. There's a lighting system put out by Lutron called Ketra, where there's a microprocessor at every bulb, which is incredible. I mean, it's just, so now we've gotten into a world where power quality and power reliability are really lifestyle, really have severe consequences to your lifestyle and comfort. And that's very difficult to place a value on. And I would say we are at the very, very beginning of this wave. I will tell you, 10 years ago when started developing the RoseWater product and started RoseWater, people weren't even talking about it. And it's taken a long time to now, we were both at CDA, Ben, and now everybody's talking about energy and everybody is confused as can be. So it's great. It's really, for those out there, it really is just the beginning of the era. Its time has come to be.
Well, what's been interesting too is it feels like, and this is my opinion, Joe, I'm not speaking for everybody, but it feels like the conversation around energy has really been almost restarted, right? For example, here in Texas, right? We had a massive power outage a number of years ago. Winter storm basically took out our entire grid. That was our point of contention. But for other folks, it's energy prices. For other folks, it's sustainability. So we've got all these weird areas of the energy community where people are asking a lot more questions. And you kind of touched on it, right? As we integrate our homes to be fully reliant in many cases on effective and meaningful electricity and power, the implications of an outage are far higher. So yeah, I think that it makes a lot of sense for people to have questions, right? And look, kind of uniquely in the residential side of the world, the end user and decision maker community, typically being the homeowner or the facility manager, they get to go direct to folks and ask questions, right? There's a little bit less of a decision making chain because a lot of times you're talking to that decision maker. So an end user like myself now is going directly to a RoseWater, is going directly to an integrator and asking these questions. What are some of the most common questions you're hearing from the homeowners and decision makers and even the facilities managers, things like that, specifically about incorporating power management as a whole into their new systems?
It is interesting because the questions have encompass a wide range of areas, but the first question is always, can I run my whole house on batteries? That's the very first question. And because people don't understand what it means to run an entire house on batteries and how much power, how many batteries that actually requires, it becomes a very difficult and in many cases disappointing question or answer for the clients. But that's very, very typical. And then we have to make them step back a bit and say, okay, let's talk about what problem are you trying to solve? And that's where it gets very difficult because, look, in Texas, when you had that week-long power outage, the only problem people were trying to solve is the grid's down. I don't want to be down. What's that going to take? And, that's a once every century or maybe once every 20-year event. That is not an everyday event. What is more everyday is how do you solve the problem when the power outage lasts for a second? How do you solve the problem when the power outages last for a couple of hours? And, you have to give people perspective on what they're trying to solve. And there are people who come up and say, well, the equipment in my house constantly needs rebooting. But what happens is they don't relate that to power. So it requires our integrators, our dealers, and incumbent on the RoseWater team to really interview customers to try and quantify what their problems are. Because as we were discussing off air, there are many solutions. There are people who provide just battery backup. And battery backup is really a generator replacement. It does not solve power quality issues. Then there are people who just provide renewables. Well, renewables, one, only work in the daytime. And two, depending on how they're hooked up, a lot of clients don't know that when the grid goes down, the renewables don't work. Because renewable without battery is set up just to sell back to grid. So, there are all these sort of half-truths that are out there, total misconceptions. And what it's really taking now is for either the system integration community, our community, Ben, to take the lead and say, wait, energy is a hot topic. Let's talk about what this means to you. What is going to be the solution for the problems that you are seeing? And that's been our struggle. And I think that's the industry struggle. It is being aided now because so many people, because of Texas and then the heat wave over the summer, which created massive power problems everywhere, um, has at least now started people saying, wait, I have to find out about this topic. And then we have to bring them back and then say, okay, we're going to educate you, because experts in the area are few and far between. And if we, not just Rosewater, but our integrators, establish the expertise, we will ride this wave, and it'll be a big one.
You're exactly right, and I've seen that firsthand, even in my personal neighborhood, right, where folks are more inclined. Like I said, in my neighborhood, this isn't a global statement, but in my neighborhood, folks are more inclined to ask those power questions to a local integrator here in Dallas called Star Power, right? Who installs the home theaters, all the whole home automation, including the furnitures and design process. They're more likely to get the question about renewable power than the electrician, because people tend to loop in the technology and the mysticism with the, oh, I'm paying an integrator, they need to figure it out, they know what they're doing. But that's not always the case, right? The reality is many of these folks, even folks that I know very, very well, are technology experts, right? They're great at installing systems and, dressing cables and making things look awesome, but they're not always the best when it comes to higher voltage, right? One of the things that you mentioned was the expertise more the low voltage side, but not quite the high voltage. What are some of the things that the integrators specifically, and maybe the answer is punting the question to an electrician, but what are some of the ways that the integrator community specifically can learn a little bit more and help better support that user and that buyer community?
Again, this is a terrific question, and we deal with it constantly. And what the integrator has to understand, and to your point, why did the integrators get these questions? And it is because the equipment that we put in, we, the integration community, put in, is really the first line of equipment that is affected by power problems. Oh, my power glitched and none of my stuff works. My network's not working. So they first go and say, you got to sell me better gear. And then it becomes an energy problem. But what do they have to learn? And this is where people overly complicate it. Because what we provide with people, here's a checklist. In fact, we have something called a document that's called a power plan document. And what we ask the client and what we ask the integrator to do is ask the client, okay, what systems in their house are the most critical, are the most microprocessor intensive? And we just have them make a list, because all of the power consumption of those systems is readily available. And then you can add up the power consumption. There are some derating formulas that we provide them. And we go, okay, based on what you want to protect, this is the size device for you. And it really is that simple. We're afraid of it because we think if we make a mistake, oh my God, if we make a mistake, nothing's going to work. All the breakers are going to trip. The client's going to be mad. Everything's going to be horrible. But it is really, as long as you can do the arithmetic, and I'm not trying to underplay this, it really is not very difficult. And even in houses where, I don't know everything that's connected, this house is old, we end up telling them, look, take a fluke meter or something that you can clamp the input, turn everything in the house on, just turn it all on. And we can tell you what max draw is immediately. And you can design a system just from that. The rest of it is really, like in the case of our product, which obviously I'm not objective, but it is the most complete product. The electrician is 4 wires in, 4 wires out. And, as we were discussing off air, one of my technicians is on site at all times to make sure the 4 wires are attached properly. But it really is not as difficult as we think. And, Ben, trying to overcome that and let people know, hey, this is not that hard, and people will not believe us until they actually go through a couple of these. And it really, that's it. Okay, what is it? And we were doing a project, I guess last week or week before. This house is on the historic register. It's, God knows where the writing is, and how are we going to do this? And I'm going, okay, this is really simple. let me speak to the electrician because he's going to have the meter, put it there. And 2 weeks later, we had all the data. Here's the size, we can do your entire house. It's done. And then from there, you can also tell them how long is it going to run with the batteries.
I see now I feel like an idiot. It's just math. No, but it's funny because at the end of the day, right? It is silly to try and oversimplify everything, but if you can calculate the wattage and the amperage and the usage rates, it's very, very simple, like you said, to help proactively build a lot of these systems. Now, where it gets interesting is you start talking about, it's typically, for the most part, traditional electricity, our provider down here, Encore in Texas, right? Very, for the most part, reliable. You know what you're going to get, electricity to the home, pretty standard. But the wrinkle is when you start talking about renewables, right? And I think that's where a lot of the modern day mysticism comes in, because I get a text and phone calls probably once every single day saying, hey, we're in your neighborhood. We are solar guys. We'd love to install these on your house. You're going to save money eventually. Nobody can tell you exactly when. So you've got folks like that are calling the homeowners and decision makers and end users that are kind of being a little bit secretive and don't really want to tell the whole truth. And then now you've got these folks asking questions to the integrators, installers, their power community friends, their homeowners association, whatever. And nobody actually has a really good answer because there's kind of this little secret snake hanging around in the back. But one of the things that you were telling me about whenever we had a chance to meet previously is that there are actual calculations based on things like square footage and time of day and location, where you can actually calculate a lot of these things, whether it's the amount of electricity a sun will create or wind or whatever. So that actually is kind of the math side too, right? Elaborate a little bit more kind of on that renewable side, because that's really where a lot of folks don't quite know where to go.
Exactly. And it really is. There are multiple levels. There are the renewable itself, a solar panel, and without getting too deep in the weeds, on average on the earth, the sun puts 1 kilowatt, 1,000 watts per square meter on the earth. That is the upper limit. Now it varies depending on latitude and altitude, but that's the global average. A solar panel, a really good one, is 20% efficient. So that's 200 watts a square meter under ideal conditions. You can sit down and calculate, okay, if my house consumes 3 kilowatts on average, right? And you're doing 200 watts a square meter. I'll see if I can do this in my head. You're going to have 15 square meters. 15 square meters gets you, that's 3 kilowatts. Just for that, 15 square meters is a lot, because you're talking about a square meter is 3 feet by 3 feet. So now you're talking about a solar farm that's, call it 50 by 50 in feet. Where are you putting that? There are not many roofs that can handle 50 by 50 and keep the same angle to the sun. And that's at their best. So there is, and people hate it when I do the math. They really do hate it because they prefer the mysticism around it. But that's really the long and the short. But, I want to go back a bit, because all of this, these people call you up, and yes, they're going to talk about power outage, and they're going to talk about how much they can save you. And you're absolutely right. The return on investment is mythical. But I want to talk a bit about the grid itself, because when you talk about the grid, and look, from a power outage standpoint, the utilities are great. We really don't suffer. If you go to other countries where you're out 4 hours a day, every day at a minimum, the US grid is pretty good, despite all the crap we give it in the media. What is difficult is voltage control. But think about your state and my state. I live in Florida. When I moved to Florida in 1974, there were 7.4 million people in this state. And all of the little houses along the water and on the intercoastal here were 1,200 square foot winter cottages. So fast forward, here we are, 2023. The population is nearing 26 million. The only state that's got more people, 2 states that got more people than us, is Texas and California. And the only one of those 2 that's growing is Texas. because California is shrinking. But, and then just like in Texas, I was in Austin recently and watched what used to be all these nice little old fraternity houses and things that are now gigantic mansions around Austin. Um, in Florida, our 1,200 square foot intercoastal cottages are now 25,000 square feet. I don't believe there has been a power plant built in this state since 1975. So, despite the fact that air conditioning, lighting, everything's gotten more efficient, we don't generate more power. So, how can we expect power quality to be maintained? And when you start looking at utility specs, you can see, all of a sudden you see a lot of voltage sags. And voltage sags are very detrimental to all of the things we talked about. All the microprocessors. If you think about, and most people have lives, so they don't think about microprocessor design, we try and make microprocessors smaller and smaller and smaller. The biggest problem with making something smaller is how do you dissipate heat? When you lower voltage, you increase amperage, which creates heat. So now we are working against the efficiency of microprocessors with voltage. So that's a discussion we have with many of our clients saying, hey, the problems you are experiencing have nothing to do with just a battery. They have everything to do with what's gone on with the expansion of population and the expansion of the size of a house. And that's what's going on in Texas. I mean, that's what's going on in many, many states, particularly along both coasts, because everybody's moving there. So, and tying that back to the renewable, when you have that kind of fluctuation in renewables, because people don't think about, it puts out a kilowatt on average, a cloud goes by, that kilowatt is cut to 200 because you can lose 80% of your power generation just when a cloud goes by. Well, your house is really not going to like the fact that it went from a need of a kilowatt and all of a sudden you're providing it with 200 watts. Every breaker in the place trips. So, and all of those things that's why people now mitigate that effect by adding batteries to their solar. But solar and batteries only work when power's off. They do not work to help stabilize voltage. So that's part of our issue. I know that was a circuitous answer, but that's
no, it's a good one, right? And I'm by no means some power expert, right? I know enough to be dangerous just naturally through the attrition of being in the industry. But one of the things that you've seen, and this might be a conversation for another day. I know that we've gotten deep into the weeds on some of these, but you see these. I hate to stay in Texas, but Texas has like 45 ecosystems. We're fine. We represent a lot of different tastes and areas and people. We've seen in places like Austin the idea of these microgrids pop up, right? Whether it's more municipality level, right, or neighborhoods where what they'll do is they'll kind of create their own grids, whether it's through renewables or whatever. Is that something? And maybe it's more on a new build side, probably much more difficult to do on a retrofit. Is that something that you see that's an actual maybe potential solution to some of these things?
I really like the way microgrids work. And I think that for individual communities, you can build a microgrid that creates hardening, that creates our little microgrid. If you build one, we can create power stability. We can create within our system the most efficient use of all electrical generation. Because people can look at it and say, well, I'm going to build my microgrid and I'm going to have batteries and I'm going to have renewables. Well, that's really not enough, because most of the microgrids I see have renewables, batteries, generators, and grid. And they have power conditioning to boot. Now you have a very hardened microgrid. You can balance, which is the cool part. You can make the grid usage at its most efficient, saying these are under the conditions we will draw from grid, which are optimal both for the utility and the neighborhood. And I think in the long run, that is going to be the answer. I saw something recently. One of the large chemical companies on the commercial side has figured out that they could, for their factories, efficiently build a micro nuke. So they are going to build their own nuclear power plant to run their factories as part of their microgrid. Now, how cool is that? And that's
initiative right there.
yes. I mean, that's serious. Okay, I'm going to take this forward a big step because when you think about, we have small nuclear reactors that power submarines, so they're small relatively. So there is no reason not to do that. Obviously we have to keep uranium secure, and there are those kinds of things. But that's where I believe the future.
See that's mysticism, right? You're not getting me touching any sort of uranium enriched, unenriched. I'm out. I'm out on nuclear.
Exactly. Yeah, but think about the very fact that they are willing to take the thought experiment out and say, wait a minute, we can make this work. Because to your point, I think we were talking earlier, Ben, when we were talking about cars, hybrid cars versus electric cars, and how, especially point of view, and I think you agree, a hybrid is the way to go. You don't get rid of fossil fuels, you make them as efficient as possible. And the idea of being able to take any fuel source, be it the sun or nukes or batteries, and use it in its most cost efficient fashion is what we want to do. The rest of this is just political posturing. The answer, and every bit of math says that is the answer, is to build microgrids that will use all sources of energy in their most efficient fashion. I love that trend. It's just beginning. I think that's really great.
Well, Joe, I think that's a heck of a place to land the plane, and it's such an incredible conversation, right? Because folks like me who have traditionally lived on the commercial installation side and tangentially, obviously, residential naturally happening there. For us, power has been a conversation, normally ending with the uninterruptible power supply, right? That normally is where it ends. On the residential side, there's a totally different conversation happening that we've kind of talked about today, and I appreciate you providing context into it. I feel like we could continue this conversation for another hour or two, and look, maybe we will one of these days here soon. There's a lot of areas that we can dive deeper into. Specifically things like EV charging, right? We didn't get to that, but it's a different can of worms. But, I appreciate you coming on today, and I appreciate you having some candor and being able to kind of break down some of the trends happening in the industry, breaking down some of the math. Your expertise is invaluable. Thanks so much for joining us today.
Ben, it was absolutely my pleasure. And you could be my host anytime you like. So I would really.
Well,
it was
I
really
appreciate that. I will invite myself back, I'm sure, at some point, and I'm going to invite you all, the viewers, back as well, because we love having you. Thanks so much for tuning into the show today. And look, like and subscribe, share, take all this information and tell it to your family at Thanksgiving and over the holidays and over whatever you want to think. Because look, you just walk in and it's power is just math. Maybe you can look awesome in front of your family and friends too. But look, we appreciate the conversation today. So much fun having you join us. Be sure to tune in next time.